In Part 6, we shift to the strategic perspective, focusing on security, compliance, and return on investment, or ROI. This section examines the strategic value of intelligent file transfer. Chapter 32 explores redefining transport security. We'll look at security as a matter of structure, not just the path of the file. Traditional security often focuses on path protection, such as SSL or VPN usage. Real security, however, depends on how many times the file is replicated, where it is stored, and who has access. Intermediate servers introduce risks like file persistence and increased audit targets. Zero-copy architecture eliminates this intermediate storage, resulting in a reduced attack surface and minimized leak paths. A full-span encryption strategy, like AES 256 encryption before transfer, protects the file body, file name, and metafiles. This prevents information leakage, even if packets are exposed. Chapter 33 discusses integrity assurance and tamper resistance. For reliable transfers, especially over long distances, organizations must verify that files arrive exactly as they were created. Hash-based verification, using AES 256, automatically detects tampering. This structure helps detect network corruption, changes during transfer, and malicious attempts to alter the file. Perfect state recovery uses chunk-based transfer to retransmit only damaged segments. This is a full state restoration strategy, ensuring the file arrives completely and correctly. Chapter 34 covers audit and traceability in enterprise transfers. File transfer systems must provide clear records to reconstruct the complete history of file movement for operational and regulatory needs. Transfer traceability must include the start and completion times, source and destination systems, and the transfer result. Enterprises need to track how files move across systems reliably. Many industries, including financial and healthcare, require verifiable transfer records. Audit requirements often include transfer logs, evidence of file integrity, and verification of completion. Operational visibility through monitoring and logging provides clear operational records. This supports faster failure detection, troubleshooting, and compliance audits for large-scale operations. Chapter 35 addresses compliance and regulatory response. Transfer architecture must support compliance by controlling where files exist and how their movement is recorded. File export regulations control file transfer to authorized parties. Intermediate storage increases regulatory risk. Direct transfer architectures, with central policy management, reduce compliance exposure. Internal audits require transfer history, integrity records, and evidence of applied policies. Transfer activity must be automatically recorded, generating systematic compliance evidence. Transfer architecture must support compliance standards like GDPR, HIPAA, and ISO 27001. Features like automatic deletion, zero-copy architecture, and comprehensive logging help meet these demands. In Chapter 36, we focus on return on investment, or ROI. The core idea is that ROI comes from structural improvement, not just cost reduction. Traditional transfer requires significant setup like server installation and firewall adjustments, which can take hours or days. Immediate connection after subscription reduces preparation time to less than 1 minute, accelerating project starts. Retransfers, where large files restart after an interruption, create significant cost in high-volume environments. Structural improvements like resume capability and chunk-level retransmission ensure only damaged segments are retransferred. Automation leads to reduced operating personnel. Before automation, staff managed logs and responded to failures. After automation, personnel focus on policy design and monitoring, shifting the operational structure. Traditional environments require VPN expansion, maintenance of intermediate servers, and extra storage. Architectural improvements, like zero-copy transfer and auto-connect, reduce VPN dependency and intermediate storage costs. Chapter 37 focuses on redefining total cost of ownership, or TCO. We'll examine how automation changes the true cost structure of file movement. Direct costs, such as transfer servers and software licenses, are easy to calculate. However, these rarely represent the full investment. Indirect costs often accumulate and exceed direct expenses. These include human resources for failure response, troubleshooting, audit preparation, and security incident response. Chapter 38 provides the strategic conclusion. File transfer is essential infrastructure in the file supply chain era, shifting its perception beyond a simple IT function. File transfer is not merely an IT function, It supports manufacturing competitiveness, financial reliability, medical safety, public transparency, and cloud scalability. We are entering the age of design. After introducing servers and cloud infrastructure, the next critical step is designing file flows. Digital transformation requires designing how files move between systems. Execula is defined as a file supply chain design platform, a network complexity removal engine, and an automation-based operational architecture, not just a simple transfer tool. The final epilogue looks toward the future of intelligent transfer, where files grow in volume and complexity, and security requirements increase. The key takeaway is that organizations must shift to designing file flows, not just storing files. As files grow, networks become complex, and security increases.